Okay, now let us discuss question number 13. So question number 13 says a sum of rupees 1000 is invested at 8% simple interest per year. Calculate the interest at the end of each year. Do these interests form an AP? If so, find the interest at the end of 30 years making the use of this fact. Okay. So question is very simple. It says there is a sum of rupees 1000 is invested at 8%. So it means if you put money in, let us say, fixed deposit or in your savings bank account, the bank used to pay an interest to you for keeping your money, okay, because it's your money and bank is using that money to provide loans and for other services. So since bank is using your money, they will pay you an interest, and in the question it says that interest is 8% per annum. Per annum, that is per year. So 8% simple interest. Simple interest means that whatever the money that you keep in the bank will pay interest only on that money. As you know, there are two kinds of interest. There are two methods of calculating interest. One is simple interest and second is compound interest. In compound interest, it says that the interest will be compounded. Compounded means you will get interest on interest. So there is a big discussion on simple interest and compound interest and the methodology to calculate that, but that is not our concern. We just know that simple interest means interest on the amount that you have invested. So question number 13. So you have invested an amount of 1000 rupees. So this 1000 rupees will be known as your principal. Okay, this will be your principal. Principal is rupees 1000. So you have invested this much amount of money. Okay, and the bank is paying you interest at the rate of 8% per annum. And what is the methodology to calculate the interest? It is simple interest. Okay. Now, what is the formula for calculating the simple interest? The formula for calculating the simple interest is principal into rate into time upon 100. You know this formula very well. You have been doing this formula since your class 6th, because in the 6th class, first time you have studied this formula, and from then you are using this formula, you are studying this formula every time, every year. Okay. So I am not going in the details of this formula. It's just principal into rate into time upon 100. This is the formula. How this formula is obtained, that is not our concern. Okay. So according to this simple interest formula, I can calculate the simple interest for any number of years, for any given years. What it says? Because simple interest depends on time. Okay, principal, rate and time. So if I ask you what is the simple interest for first year. Now what is meant by simple interest for first year? Let us take an example. If I keep my money in the bank on 1st of January 2015, then if I keep my money for the whole year, then on 1st of January 2016, that is the next year, the bank will pay me an interest. Okay, in that way we will calculate the first year. I have kept my money, and after 1 year the simple interest for that 1 year will be equals to principal into rate 8 into time. Time will be in years. So how many years? It is 1 year. So this will be 1 upon 100. Okay. So by solving this you will get rupees 80. So what is rupees 80? Rupees 80 is the interest paid by the bank to me, or the interest obtained by me is in first year. Okay. So if I keep my money in the bank for 1 year, bank will pay me 80 rupees more after 1 year. एक साल बाद बैंक मुझे 80 रुपीज और देगा, मेरे 1000 रुपीज मुझे देगा, साथ में 80 रुपीज भी दे देगा. Okay, as an interest. So this is simple interest for first year. If I ask you what is simple interest for second year, simple interest for second year, or after 2 years, simple interest after 1 year, let us write it as after 1 year, and let us write it as after 2 years. Okay, we are not calculating individually for years, we are calculating it cumulatively. So this is after 2 years. So simple interest after 2 years will be 1000 into 8 into 2, because I am keeping my money for 2 years in the bank. So upon 100. Solving this is 0, this is 0, this get cancelled, and you will get rupees 160. So if I keep my money in the bank, after 2 years, bank will pay my 1000 rupees to me, plus bank will pay additional 160 rupees, because I have kept my money in the bank for 2 years, okay, for 2 long years. After that, if I calculate simple interest for, or after, if I calculate simple interest for after 3 years, okay, so after 3 years, bank will pay me an interest of principal into rate into time is 3 years upon 100. So this 200s will get cancelled, and 3 8s are, it is 24, so rupees 240. And after 4 years, the same process, after 5 years, the same process, the sequence, the interest will go on. So what you can observe, you will see after 1 year, the interest I got is rupees 80. After 2 years, interest I got is rupees 160. After 3 years, interest I got is rupees 240, and so on. In this way, I will get rupees 80, then 60, 160, then 240, and then so on. In this manner, I will get interest from the bank. Now, can I observe a pattern in the simple interest that I am obtaining from the bank? Yes. In the first year, I got 80 rupees. In second year, I got 160 rupees. It means I got rupees 80 more compared to first year. If I keep my money for 1 more year, I will get 80 rupees more compared to the first year. And if I keep my money for 3 years, so I will get more 80 rupees. That is the rupees 240 for 3 years. So for 3 years, I will get 80 rupees more compared to the second year. Okay, second year के comparison में ये वाला third year का जो amount है, this is 240, which is 80 more than previous year. If I say that let the interest obtained in the first year is the first term, okay, interest obtained in the second year is second term. If the interest obtained after third year is third term, so I will get a pattern as 80, 160, 240, and so on, and I will say this is an arithmetic progression, because the difference between two consecutive terms is a constant. It is a constant. That's why I am saying that this is an arithmetic progression. So what is the first term in this arithmetic progression? The first term in this arithmetic progression is 80. And what is the common difference in this arithmetic progression? D is 160 minus 80, that is equals to 80. So the first term is 80, and the common difference is also n is also equal to 80. Now let us understand what this question wants to say. It says that calculate the interest at the end of each year. So this is what we have calculated, the interest at the end of each year. Okay. After that it says, do these interests form an AP? Yes. I can very clearly see the interest obtained after 1 year, 2 year, 3 year, 4 year, 5 year, and so on will form an arithmetic progression. So can I directly calculate the interest after 4 years using this AP, using this pattern only? Yes, I do not require this formula. I can see that this is 180 more than the previous year, this is 180 more than previous year. So what will be the interest in the fourth year? The interest in the fourth year will be 80 more than the previous year. So 240 plus 80 will give you 320. So this is the interest on this is the interest after 4 years, okay, and so on I can calculate. So this is, you can see the practical importance of the arithmetic progression. Here I can calculate the interest of any year without using the formula for simple interest. I can just observe the pattern of interest and I can calculate interest, okay. So do these interest form an AP? Yes, they are forming an AP, and if so, find the interest at the end of 30 years making the use of this fact. So what I need to calculate, the interest after, I need to calculate interest after 30 years. Now if I want to calculate interest after 30 years, what does this mean in my question? What does this mean in my arithmetic progression? It means this particular statement implies calculate the 30th term of AP. Why? Because interest after 1 year is the first term of this AP. Interest after 2 years will be second term of this AP. Interest after third year will be third term of this AP. Interest after fourth year will be fourth term of an AP, of this AP, and so on. Interest after 30 years will be 30th term of this AP. So 30th term, what I simply need to calculate is the 30th term of this AP. So what will be the formula to calculate the 30th term? So T30 will be equals to A plus, in place of N I can write 30 minus 1 into D, okay. T30 will be T30 is equals to A plus 30 minus 1 into D. So let us substitute the values. A is 80 plus this is 29 into D is again 80. So 80 plus 29 into 80. What I can see is, take 80 as common, it will be 1 plus 29 only, okay, and this will become 80 into 30. So the interest after 30 years will be 2400 rupees, okay. So interest at the end of 30 years is equals to rupees 2400, and this is our answer, okay. So what you can see, this question is not at all difficult. It is the application of arithmetic progression in calculating the simple interest. Just try to correlate the two things. One is simple interest, one is arithmetic progression. So we are relating the two topics into one, and we are calculating the interest using arithmetic progression, using the concept of arithmetic progression, okay. And this type of question you will observe, these are very important question. Application based questions are very, very important. You will find the application of this arithmetic progression in geometry, in algebra, in statistics, and in every other field, okay. Statistics is the biggest example where you can see the application of AP. So this is how you can solve question number 13. We will observe more questions which are application based, and you will enjoy those questions, okay. So you can note this. Okay, let us now discuss question number 14 from the practice sheet. Question number 14 says, in a flower bed there are 23 rows plants in the first row, 21 in the second, 19 in the third, and so on. There are 5 rows plants in the last row. How many rows are there in the flower bed? Okay. So what is a flower bed? Flower bed is just an area in which you plant the plants, okay, in which you plant the flowers in a row, okay. For example, question number 14, let us say this is a flower bed. In this flower bed, what I am going to do is I am going to plant the flowers in this way. In this way. This is what? This is row wise plantation. Okay, row wise. This is the first row, this is the second row, similarly the third row, like this, and so on till the last row. Because depending on the size of the flower bed, you can plant the rows, because you cannot plant infinite number of rows in a flower bed. Okay, so like this is a flower bed, and we have row wise plantation of flowers. Now it says in this flower bed there are 23 rose plants in the first row. So in the first row there are 23 plants. So let us say this is the first row. Let us name this as the first row. This is the first row, this is the second row, this is the third row, and this is the last row. It is given that there are some rows, and in this sequence they are planted. Now in the first row we have 23 rows. So the first row has 23 rows planted in it, like this. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on up to 23. In the second flower bed we have 21 rows planted. Okay, there are 21 rows in the second flower bed. In the third flower bed, in the third row of this flower bed you have 19 rose plants. Okay, the 19 rose plants are placed in this third row and so on. And in the last row I have 5 rose plants. Okay, I have 5 rose plants planted in the last row, like this. Now what it is asking is how many rows are there in the flower bed. So what I need to calculate, I need to calculate the number of rows that are present in this flower bed. So how we can calculate the number of rows that are present in this flower bed? It's again a practical situation. What you can see is, if I observe the number of plants planted in each row, they are 23 in the first row, 21 in the second row, 19 in the third row and so on up to 5. Like this they are planted. This is the first row, this is the second row, third row and the last row. What you can observe is, this is an arrangement of numbers. Some numbers are arranged in this manner, that is in decreasing order. You can see first is 23, 21, 19 and so on. If I observe these numbers, what I can find is the difference between the second row, the number of plants in the second row and the first row is 2, that is -2. And the difference between the third row and the second row is again -2. So what I can say, that there is a pattern that is followed in plantation of flower plants. Okay, the pattern is, in the first row I will plant 23 flower plants. In the second row I will have 21 plants. In the third row I have 19 plants, and in the last row I have 5 plants. So what I can see, the pattern is basically an arithmetic progression, because there is a common difference between all the consecutive terms. The difference between two consecutive terms is a constant value, or I can say the difference between the number of our flower plants planted in 2 consecutive rows is a constant. So in this AP I can see the first term of AP is 23, and this AP can continue till infinity, but practically we have a limited size of flower bed. That's why I can only continue this AP up to 5. That is, in the last row I can plant only 5 rose plants. Okay, so I will say that this AP is terminated at this value. Okay, this particular AP is terminated at this value. So this 5 will be known as the last term of AP. So what is the last term of an AP? The last term means the term at which AP is terminated. जहाँ पे AP को रोक दिया गया वह टर्म हो जाएगा लास्ट टर्म. नाउ इस AP के अगर मैं फर्स्ट टर्म की बात करूं तो वो 23 है, दैट इज A इज इक्वल्स टू 23. ओके, और इस AP के अगर मैं कॉमन डिफरेंस की बात करूं तो दैट इज -2. ओके, सो क्लियरली समझ में आता है ये एक डिक्रीजिंग AP है. और इसके लास्ट टर्म की बात करूं तो दैट इज 5. नाउ अब खास बात ये 5 कौन सा टर्म है ये हमें नहीं पता. हमें उस टर्म का वैल्यू जरूर पता है लेकिन हमें पोजीशन नहीं पता कि ये 5 कौन सा टर्म है. 8th टर्म है, 10th टर्म है, 12th टर्म है, 100th टर्म है, 99th टर्म है, कौन सा टर्म है ये नहीं पता. सो लेट अस अज्यूम दैट let 5 be the nth term of this AP. So what I can write? I can write Tn is equals to 5. And what is the formula for Tn? The general term. The formula is A plus n minus 1 into D. Okay. So Tn is equals to 5, which is equal to A plus n minus 1 into D. Now just observe this particular condition. In this condition 5 is equals to A, where A is given as 23 plus n minus 1 into D is minus 2. D is what? D is minus 2. So I need to calculate the value of n. I can calculate the value of n from this condition. It's because it is given that the last term or the nth term is 5. We have the value of n, we have the value of Tn, we have the value of A, and we have the value of D. So what you need to do is just calculate this. It will become, now let us take this term here. So it will be 2n minus 2, or 2n is equals to 23 minus 5 plus 2. So this will give you 2n is equals to 23 minus 3, that is equals to 20. So the value of n will become 10. Now what does this 10 represents? What does this value of n represent? N is the position of this 5, n is the position of this term, and this term, the position of this term represents a row. This is the first row. The position of 23 as the first term of an AP represents the first row in this flower bed. So similarly, I am relating the two things. I am relating the mathematical position of this 5, okay, to this practical row of a flower bed. So n represents position of five in AP, as well as it represent the position of last row in flower bed. So what is the last row in flower bed? The 10th row will be the last row of the flower bed, and the 10th row contains 5 flowers. This is in practical situation. If I talk about in arithmetic progression, I will say 5 is the last term of this AP and the position of this 5 is 10. That is, it is the 10th term of this AP. Okay. So our answer is 10. So the last row of this flower bed is 10. So it's a simple question. It's just an application of the concept of arithmetic progression. Okay. Now let us discuss the next question. Next question is 15th one. Find the number of terms in each of the following APs. Okay. So it says that number of terms. You need to determine the number of terms. If question comes as find the number of terms, then you can judge very easily that the particular AP, the given AP should be a finite AP. It should have a finite number of terms. otherwise AP can continue till infinity, but as our requirement, जैसा कि मुझे चाहिए, अगर मैं चाहता हूं कि मैं एक AP को टर्मिनेट करा दूं, किसी एक पॉइंट पे रोक दूं, तो वो चीज मैं कर सकता हूं। जैसा कि क्वेश्चन नंबर 15 में, क्वेश्चन नंबर 15 फर्स्ट पार्ट, AP is given as 7, 13, 19 and so on till 205. Now, क्या ये AP 205 के आगे नहीं जा सकती? जा तो सकती है, बट मैंने इसे सिर्फ यहीं तक लिखा, मैं इसे सिर्फ यहीं तक कंसिडर करना चाहता हूं, दैट्स वाई ये AP 205 पे टर्मिनेट हो गई। इससे बड़ी वैल्यूज मेरे काम की नहीं, इसीलिए मैंने उन्हें छोड़ दिया। ओके, सो वी नीड टू डिटरमाइन द नंबर ऑफ टर्म्स इन दिस AP. So what exactly is meant by the number of terms in this AP? If I say 205 is the last term of this AP, then the position of 205 will represent the number of terms in this AP. Okay, try to understand what I am saying. I am saying that position of last term is equal to number of terms in this AP. Okay, because if I say that the position of 205 is, let us say, 100, so it means 205 lies at the 100th position. It means there are 99 positions before 200 and 205 is the 100th position. So it means that this AP contains 100 terms. This is a very simple concept. So let us say, let 205 is the nth term of this AP. मैं मान लेता हूं कि 205 is the nth term of this AP. Now, if 205 is the nth term, मैं बड़ी आसानी से लिख सकता हूं कि Tn is equals to 205, which is equals to A plus n minus 1 into D. Okay, Tn किसके बराबर है? 205, और Tn मतलब जनरल टर्म, that is A plus n minus 1 into D. Now, observe this condition. In this condition, मेरे पास A का वैल्यू है, मेरे पास D का वैल्यू भी है। कैसे? बड़ी आसानी से निकाल सकते हैं। The value of A is 7. Now I will not tell how you have calculated the value of A because you know it very well, and the value of D is 13 minus 7, that is 6. Okay, so using this condition I can write 205 is equals to A, that is 7 plus n minus 1 into 6. N minus 1 into 6. So now bring 7 in to LHS from RHS. 205 minus 7. So 205 minus 5 is 200, and 200 minus 2 is 198. So this will give you 198 is equals to n minus 1 into 6. So I can get n minus 1 is equals to 198 upon 6. Okay. This will give you 6 3s are 18 and 6 3s are 18. So that is 33. So the value of n you will obtain is 34. Okay, because n minus 1 is 33, so n is equals to 34. So the position of this term 205 is 34th. It means in this AP, this 205, that is the last term, lies at 34th position. So it means there are 33 terms before this 205. So how many terms total are there? How many terms in total are there in this arithmetic progression? You will find total 34 terms are there in this arithmetic progression. So it implies there are 34 terms in this AP. Okay, there are 34 terms in this AP. So this is the first part of question 15. Now second part आप solve कर सकते हैं. Second part is similar to first part, just a calculation. Take minus 47 as the nth term and calculate the value of n. That is what you need to do to solve this question. So I am not solving the next part. So this is the solution for question number 15. Okay, this is only the first part. You need to solve second part yourself. Okay, so first you note this, then we will solve the further questions.